Okay, so I'm going to assume you guys know how to download things from the internet. And I'm going to assume that once you download it, you'll know how to open it. So open your Anaconda. So in my case, I'm going to type, so I'm in Windows environment right now, but so I just type in Anaconda Navigator. Can you see that, Kate?
It's really small, but that's fine. I've got a Mac, so it's going to be different.
Okay. It's not going to be significantly different, but yeah, anyway, so you'll pull up the Anaconda Navigator. So it's going to take maybe 10 seconds or so. And you'll see this little green icon. It is initializing. And so what Anaconda is, really good, especially for beginners, is if we have, it'll handle all the dirty work for you. So if you have multiple versions of Python and multiple different libraries that work with different versions, it can be, and different environments, it can be very, very painful. Now, what Anaconda does is simplifies it. You can switch between Python 2.7 versus 3.0. You can use different libraries and so forth. It'll handle all of that for you. So it'll significantly reduce the headache that you have in debugging any issues you might have. For whatever reason, it's taking a very long time. Oh, no, here it is. So once you're here, you'll have this little dashboard. So don't worry about these other things, and don't click on, well, you can, but I just click on the Jupyter Notebook, not the Jupyter Lab. You just push launch. So it'll again take another, I don't know, 10, 20 seconds, and hopefully it'll pop up. Oh, great. So here it's popping up in my Chrome browser. And then I've already outlined this in your tutorial, but basically, let me see. Yeah, here it is. So what you need to do is you need to start a new notebook, and here just click Python 3. And then it might take a few seconds. And so as I describe in the tutorial, here's your command line. And so now you're basically ready to start coding. So I'm going to go to the tutorial now and just sort of walk you through the main pieces, the things where people might have some trouble. So here's tutorial Python. Oh, no. Okay. Okay, so we're at this step here where we clicked on launch. Now, if you, for whatever reason, you guys need further instructions, which I don't think you'll need, like I've tried to simplify this as much as possible. I have provided you a few more links in case you need further help on how to launch Jupyter or how to navigate it. So at this point, you can go to your Moodle, and then these points here. Apologies for the kids in the background. Hopefully they'll go to bed soon. Here are 4 main .csv files. And the main issue here that a lot of beginners will have is that they'll sometimes save it as an Excel file versus .csv. And you want to keep it as a comma delimited file, .csv file. And the other common trip up is the file path. So in my case, I've saved, I've downloaded from Moodle into my C drive, and then a folder that I've labeled as Python scripts. And then, so these are for the 4 different files that I have here. Homeprice.csv, homeprice multiple variables.csv. Hold on, Kate, I apologize. Hold on.
No, it's okay. I understand the child issue.
Okay, so at this point, you should have been able to download the 4 files and put it into your folder. I've labeled Python scripts. You can call it something else. I think for simplicity, just call it Python scripts. And please be aware of whenever you're coding, just be aware. I mean, I don't think in this case it's going to matter, but just be careful of the lowercase and uppercase. It's just a good habit to make sure everything is
consistent.
consistent, exactly. So we're talking to machines, and in some ways, machines are very dumb. If they're just going to take exactly what you give them, so you have to be very careful. And hopefully, yeah. Anyways, hopefully you're detail oriented, because that's one of the banes of being a developer. So
I work in HR information systems. Shit in, shit out. Data integrity is really important.
yes, exactly. Great. So once you're here, then we can start in step 3, which is just you can start coding in Python. So we've already downloaded this tutorial. So what I'm going to do is now I'm going to hop up to the actual problem set. And just to let you know, we can go over step 4, but these are your prompts that you can choose for this week. So now we can actually go to the problem statement. So this week we've got the first one, which is a linear regression with one variable. And so you're being tasked to predict home prices in Monroe, New Jersey, in the United States. So we're only going to take a very small sample just so that you guys don't get overwhelmed with data. But hopefully you can generalize this 5-row, 2-column data set into what could be millions and millions of rows. And this is where machines are super helpful. So your task is to build a machine learning model that can predict home prices based on the square feet area. So we just recently came to Sydney, and we were looking at the ridiculous house prices here. And this is something that you guys can do as well. You can actually use this in your practical day-to-day life. And so let me explain to you how this works. So in principle, you basically have a bunch of houses that have different areas to them. And here we just show 2,600 to 4,000 square feet. I think here it's in meters squared. You'll have to do the conversion if you want to do this in Sydney or in Australia. And then you have the prices here on the y-axis. And this is your dependent variable as a function of your independent variable. Now, you can draw out different lines, again, as we discussed, but for us, we want to choose the best line. And what is the best line? For us, it's the total sum of errors, which is how you minimize it. And so here we've just summarized your home price is a function of the slope here times the area plus your intercept. So now we're ready to go to do some machine learning in Python. So the first thing I'm going to do, I'm going to see if maybe I can't do that here. So I'm going to here. So I'm going to show you maybe one example or a few examples. So I've created this other document for you guys. It's called tutorial copy paste text. So I'm just going to do the first set. So here you're just basically importing your libraries. So I'm just going to type here, and you're not going to see anything happen yet. And so let me just break this down for you really quickly. So first you're importing this library called pandas, which is just a library in Python that allows you to read data frames. So it allows you to read your Excel, or sorry, your comma delimited file, your spreadsheet. In this case, it's your 2-column, 5-row data set. We have NumPy that allows you to do your numerical computations. And one of the most important ones for us today is the sklearn or scikit-learn, where you're importing the linear regression model. And then last but not least, you're importing your MATLAB PyPlot library, which we're just going to call PLT. So everything here is just like simplified PD, NP, just so that it's easier for you to write. So all you need to know if you've never coded before is there's a lot of work that's been done behind the scenes here to make this super easy for you guys to complete this exercise. So the next line, we're going to go here. We're just going to copy and paste. And so what we've done here is df is called our data frame. And we're just reading in the file that I put here. Yours might be slightly different file path. I just put mine directly on the C drive just for simplicity of demonstration. I put in a folder called Python scripts. And then here's my first data set here. Make sure there's single parentheses, not double. Otherwise, it's not going to read it. Nope. So then you need to go to You can push either this button or you can push this button to run it. And here, as you can see, this is my data set that I read out from the .csv file. So maybe I'll pause here first. Any questions at the moment?
No.
Okay. So what I would say is, at this moment, don't worry about any of the terminology. Today is just copy and paste. I can explain to you very briefly what each of these commands do. So in this case, so the next set of things, all we're doing is plotting the X and Y axes. So it's called X label, Y label. We're going to plot the area and price. So now we can visualize this data set. And then there we go. So now you'll see that we've plotted the 5 different points that represent the area and price located here. Spreadsheet. So I'll do this for this exercise just to walk through what each of this means, because once you go through this, everything else will be basically a variation on theme. So here, all we're doing is we're going to drop the price column. And then we're going to look at price, just to show you the different commands. So here you see the price. Now, one of the more important ones here is what we're going to do now, which is you're creating your linear regression object. And I'll just let you know that whenever you put a hash here, that means that it's not going to be considered by the machine. So you can do whatever you want. And I just label it just for simplicity for you guys. But here we're starting to build our linear regression model. And now we can predict what a 3,300 square foot house would look like based on this data set. So just regression.predict. Okay, so that's all you need to do. This is your method. And it's going to predict this price here. So $628,715.75 is what it would cost in Monroe, New Jersey. And then just for completeness, we're going to show you what so I'm really happy you asked that question of, what does that equation mean, Kate, because this is the coefficient and this is the y-intercept. So now we can see what it says here. Oh, so actually, I should do this one at a time. So your coefficient is going to be 135.78. That's your rise over run for every square foot. That's how much it goes up in price. And this is where it starts off. The y-intercept starts off at $180,616. So just to make sure that we're all on the same page here, and just to double check that we haven't done anything funky here, I'm going to do the y equals mx plus b again. So here, so we have the, this is your m. So I actually did this a little bit different. And then this is your x. This is what we're predicting, our independent variable is 3,300 square foot and plus the y-intercept. And then it should come out with our original prediction here, 628,000. So we know that it looks like it's working. So the last few pieces for this exercise, maybe I'll just pause here for a minute. Do you have any questions at the moment?
No.
Okay. So hopefully, I think the downloading part and getting it up and running is probably going to be the hardest thing for for some of you. But once you get it up and running, it's basically copy and paste. So now we're going to look into, we're going to read the file that we've downloaded from Moodle, which is the areas.csv. And so now we're going to have a bunch of these areas. And so we're going to predict a bunch of prices based on these. And I'm going to have a variable p, which is going to be my predicted prices. So for these three areas, I have 316,000 for a 1,000 square foot area, 384,000 for 1,500 square foot, and 492,000 for 2,300 square foot. Okay, so let's look at what so another way to look, yeah, so here's just what I was just saying earlier. So now we just put in a nicer format for you to see that the price does rise as a function of area. And these are for completely new data points on the x-axis. Now what you can do is you can assign this to your own file. And the way we do that is typing this command. So whenever you do _CSV, I'm going to write it to, again, my folder in my drive. I'm going to label it prediction.csv. And then, oh, yeah, okay, run. And now I'm going to plot what this looks like. And here we go. Here's our regression line. Okay, so that's basically, basically from here, you've built your first machine learning model to predict housing prices based on your square area footage. So if, obviously this is a very simplified data set, and we could make this millions of lines of code, billions of lines of code, and the machine would have no problem doing it. I'll just make a quick note for linear regression with multiple variables. The only thing that we're doing differently here is that now we're going to have this format here. So instead of just a simple linear regression with y equals mx plus c, we're now just going to add several different features represented by m1, x1, m2, x2, m3, x3. And these are the slopes of three different features. So for your problem set, Kate, all this means is this. So let me get up the problem set. Where are we here? So now, instead of just area, we've added two more features. So number of bedrooms and the age of the house. You could also start adding bathrooms. You could add, does it have a swimming pool, or, does it have a tennis court, or whatever, right? There could be a number of different features that you could add here. But in this particular example that we're going to do today is we're just going to, given these home prices and these features of number of bedrooms and the age of the house, build a model that predicts the price of a home for a 3,000 square foot area, 3-bedroom, 40-year-old house, and a 2,500 square foot area, 4-bedroom, 5-year-old house. So I'm not going to, unless you want me to, I can go through and just copy and paste again. But basically, I've outlined in very simple form sort of what the commands are to go through this linear regression with multiple variables. And then we're going to leave this activity, the final set of activities is going to be the hiring problem. And so, in principle, again, like this can all be done in 5 minutes, but you might want to take some time just to think about like what exactly are you modeling out here. And I wouldn't concentrate too much on sort of what do these functions mean, or what does this language mean, or just get a rough sense of like, okay, this is what the function is, and this is, I'm inputting, it's basically input output. That's all you think about. I'm inputting a independent variable. So in this case, it's going to be area. So this would be 3,000 square foot. And then I've got another feature, which is 3 bedrooms. And then the other feature set is that it's the age of the house, 40 years old. And it's going to predict, based on these 3 features, what the price should be. And in this case, it's going to be $494,408. So for the hiring problem, you're going to be basically doing the same thing. You've got to download the hiring.csv. And then, Kate, maybe you can provide color on this, but basically, in this is a very simplified situation, but in this case, you're going to have the HR decide the salary based on how many years of experience, what their test score was, and then what their interview score was. And so based on these 3 characteristics, you will predict what a reasonable salary range should be for this type of candidate. And so if you can imagine, if you can successfully do the real estate problem with the multiple variables, you should be able to do this as well. So I think I'm going to end the session here unless you have any questions, and then we can take anything else we want offline.
No, I'm good for the video. Yeah.
Perfect, great.
The recording.
So let me end the recording now. Let's see, how do I hope this was recorded.
It did say it was recording when I joined the meeting.
Okay. I'm gonna stop.
So